Hi, and welcome to Lazy Academy's Algebra 2 curriculum. Before I begin, I'm going to ask you to do two things for me. One, I need you to get a paper and pencil and actually work on the problems that I'm about to show you. This is because there's only one real way to learn math, and that's learning by doing. Two, I need you to challenge yourself by not giving up so easily. Research has shown that one of the major factors to success in school and in life is grit. Not a high IQ, not an outgoing personality, but your ability to continue in the face of hardship. And that's it. If you can do those two things, then I have no doubt that you will not only pass, but get an A+ in your math classes. In our last lesson, we went over the four-step process to solve any linear equation in one variable. In today's lesson, we're going to do the exact same thing, but this time with decimals and fractions. Let's start with an example. So here we have 19 over 5 times x plus 1 equals negative 111 over 35 plus 12 over 7 times x. The first thing to notice is that expressions involving fractions just look more complicated, but I assure you they are not. We're going to solve this problem just like we did in our previous lesson by using the four-step process, but with one difference. We're going to clear the fractions. Okay, so we clear the fractions. And we do this by multiplying both sides of the equation by the LCD of the fractions. Okay, so here we have the LCD. We're trying to find the LCD of just the fractions. So a LCD of 5, 7, and 35, well, that's going to be 35. Okay, so let's go ahead and multiply both sides of this equation by 35. On the left side, 5 goes into 35 7 times. So we have 19 times 7, which is 133. So we have 133x. 35 times 1 is 35 equals. And on the right, we have negative 111 over 35 times 35. The 35s cancel, so we're left with just 111 plus, and 7 goes into 35 5 times. 12 times 5 is 60, so we have 60x. And notice how now we have just a regular linear equation in one variable that we're used to working with. And now we can apply the four-step process just like before. So we're going to move the variable to one side and everything else to the other side. So let's do that by subtracting 60x from both sides. And we're going to subtract negative 35 from both sides as well. And the 60x's will cancel, the 35s will cancel. Here we have 133 minus 60x, which is 73x, equals negative 111, and negative 35 is going to be negative 146. And now all we have to do is isolate our variable by multiplying both sides by the reciprocal of 73, which is 1 over 73. So now the same thing that you can do is basically divide both sides by 3. Okay, this is equivalent to multiplying by the reciprocal of 73. So we're going to divide both sides by 73. And when we do that, we get x on the left side isolated, and on the right side we have negative 2. Right? 146, negative 146 divided by 73 is going to be negative 2. And I'll leave it up to you to check the solution. All right, Next, we have an equation that's riddled with decimals. So with decimals, the idea is the same. We want to get rid of the decimals. And we do that by multiplying. So we clear the decimals by multiplying by powers of 10. And we're going to multiply. The power of 10 is going to be determined by the largest number of decimal places we have. Okay, so if we're dealing with an equation with 3 decimal places, we would multiply by 10 to the third power, which is 1,000. If there was just 1 decimal place, then you'd multiply by 10 to the first power, which is just 10. In this case, the largest decimal places we have is 2. So we're going to be multiplying by 10 to the second power, which is 100. And so we're going to multiply the left side by 100 and the right side by 100. Okay, so let's do that. We're going to distribute. So 100 times 5.1 is just going to be 510. Right? You move, since there's 2 zeros, you're going to move the decimal place two places to the right. So we have 510x plus 726. And then on the right side, 7.51 times 100, well, again, the decimal places are going to move to the right twice. And 5 times 100 is going to be 5 and 2 zeros, or 500. And of course the x. And now notice we have just a regular linear equation in one variable that we're used to solving. All right, so let's go ahead and move our variables to the left side and everything else to the right side. So I'm going to subtract 500x from both sides, and then 726 are on both sides. Of course, those will cancel. 510x minus 500 is going to be 10x equals. Here we have 751 minus 726, which is 25. And now we're going to isolate x by multiplying by the reciprocal of 10, which is 1 over 10. And the same way of doing that would be just dividing both sides by 10. Okay, when we do that, the 10s cancel. We're left with x on the left side, and then 25 over 10 on the right side, which reduces to 5 over 2, because they have a common factor, a greatest common factor of 5, right? You divide the top by 5 and the bottom by 5. That gives us 5 over 2. Or if you want to put the answer in decimal form, 5 divided by 2 is going to be 2.5. Okay, and there's our answer. And once again, I leave it up to you to see if we've done it right. For the next topic, we're going to go over the 3 types of linear equations that you're going to encounter in algebra. The first type is called conditional, and this is the most common type of equation you'll run into when you're studying for algebra. It happens when you solve for an equation and you get an x that equals some number. Okay, so let's just go ahead and solve it. We're going to add 10 to both sides, and then subtract 7 from both sides. Those will cancel, and on the left side we have 5x equals negative 43, and negative 7 is negative 50. Okay, we're going to isolate x by dividing by 5 on both sides. Okay, the 5's cancel, and so we're just going to get x equals negative 50 over 5 is negative 10. Okay, notice how we just get a regular answer, x equals negative 10. And that's the conditional type of equation. The second type of equation is called a contradiction. This is when an equation gives you a false solution. Okay, an equation that's basically not true and doesn't work. So let's go ahead and just solve this one. So here we have negative 4x minus 13 equals negative the quantity of 8 plus 4x. So I'm going to simplify this. So it's going to be negative 8 and negative 4x. That's going to equal negative 4x minus 13. I'm going to isolate x by moving the 4x to the left side. And then I'm going to move everything else to the right side. Those are going to cancel. And here we have, well, on the left side, we have negative 4x and positive 4x. That's 0 equals. Here we have negative 8 and positive 13. That's going to be 5. And right away, we know this isn't true, right? 0 does not equal 5. This is false. So that's basically what a contradiction equation is when you simplify and isolate the variable, you get a false answer. The last type of equation is called an identity. And that's when you get an equation that has an infinite number of solutions. So again, let's go ahead and solve this one. This is 2x plus 5 times a quantity of x minus 8 equals negative 40 plus 7x. So I'm going to simplify. So 2x, we're going to distribute the 5. We get 5x minus 40 equals negative 40 plus 7x. And once again, we can simplify that. So we have 7x minus 40 equals negative 40 plus 7x. And notice how on the left side we have 7x minus 40, and on the right side we have negative 40 plus 7x. These two, okay, these two sides are the same. So what they mean by an infinite number of solutions is you can plug in any number into the x. So you can plug in 1, 2, 5, 0.5, 1,000 into x, and you'll get a correct solution, a true solution. All right? And it's true for an infinite number of solutions. And that's what they mean by an identity. For those of you who are serious about learning this stuff, I've included a practice quiz in the description box below. So here's the link to the practice quiz. It's a Google form, which you can complete for a grade. You can also join my Discord server, Lazy Academy, where I'll be holding cash and Robux giveaways once a week to some lucky winners who complete and pass the practice quiz. Thank you for staying with me, and I'll see you next time.